those days.
Yo, I'm retarded. I can't even do the classwork right now because I can't even.
All right, is November 7th. I am not going to be here tomorrow, so you have a sort of a review worksheet that you'll be getting to work on.
Who said you could leave?
So that'll be kind of nice, little break. But today is a really big concept talking about domain and range. Domain specifically. And domain, do you know what domain is?
Yeah, it's like the.
Yeah, domain is a hard concept. Domain refers to the X values that you are allowed to use. Right?
And then the range is a Y.
The range is the Y values, the outputs that we get out. And the nice thing is, for a lot of these things, your calculator can be really, really, really helpful. I'm always going to go to the when in doubt, graph it out, okay? Because if you're given a function that says y equals or f of x equals, then it's something you can plug into your calculator and graph. And a lot of times the answer is there. In fact, my pre-calc kids still haven't figured out that like 75% of their tests they can answer with doing absolutely no math. They know how to use their calculator. It's ridiculous.
It only works on the tests you make, though, that I plug in X. I can't do it with the pre-made tests and stuff.
So, I do, I make it a little bit harder, but yeah, so in general, domain refers to the X values that we're allowed to use. And sometimes we're not allowed to use certain X values. We might not be allowed to use X values that give us things that are undefined. Or when we have square roots, sometimes we have problems with domain. So X values that we are allowed to use. And so I'm going to approach this two different ways today. We're going to talk about domain and range graphically first, because I really like the connection between a graph and domain and range. And so I have this first example here. I'm asking, what is the farthest left X value? What'd you say? Sure, -3. You can see it right here. Here's our x-axis. And our farthest value to the left is right here at -3. And what's our farthest right x value? Infinity. Very good. This arrow is pointing sort of up, but it's going up, and it's also moving to the right, isn't it?
Yeah.
If you imagine that goes on forever, it is going to get all the way to positive infinity over there. So when we talk about the farthest left and the farthest right value, X value, talking about the x-axis for the X values for domain. So you just answered the question, what's the domain of this function? And in this case, the domain, it stops here at -3, and it goes all the way to infinity. That's domain. Make sense?
Absolutely.
So we can do a similar thing talking about range as well. And so then for range, we would look at the y-axis and ask ourselves, what's the lowest y value and what's the highest y value? Not quite 0 in this one. I didn't ask that question specifically because you can see here, there's a pretty low point right there. It's negative something non-specific. I don't quite know. So I can't figure that out here. But that's the idea for domain and range. So first, let's talk about this. So sample 1, evaluate the piecewise function. These are the two problems. I was like, whoops, I didn't mean for those to be on that assignment yesterday. Evaluate the piecewise function for the given values. This is a piecewise function, this example here. A piecewise function is basically just made up of pieces of functions, and we're actually going to be graphing these on Tuesday. So you'll see what this looks like. It's, it can be anything, but it's like a little piece of a parabola and a little piece of a line and a little piece of a horizontal constant function.
I know what you're saying.
Yeah, it's just pieces, piecemeal functions. You sort of piece it together. It's literally why it's called a piecewise function. But what happens here is you'll notice, and I really like the way that your book does this. It's telling you we have this function 4x minus 3 for x values greater than or equal to 0. Which means if you have an x value that's greater than or equal to 0, you're going to plug it into the top function. We use 2x plus 5 for x values less than 0. All right, so it's a conditional statement. And a lot of books leave out the word for, okay? So it's a conditional statement. If you satisfy this condition, then you get to use 4x minus 3. Okay, does that kind of make sense? It's a conditional statement. It's like how I train my children. If you want dessert, then you need to eat your dinner. Yeah. Mhm. Yes, it's the only way I could get them to eat.
Starve. That's what my parents did to me. I went to
They do. If they don't eat what Mama cooks, they don't get dessert either.
You got dessert every night?
Sure.
I mean, it's not like she's baking a cake every night.
Oh,
just
God, no.
No,
It's
it's
like
just
a
cookie dough in the
popsicle,
oven.
free
No,
dough,
like fruit.
otter
Fruit
pop.
is a good dessert in my opinion.
You know, like you can there's the
Ice cream.
Or like,
Okay.
buy cookie dough.
All right, ladies and gentlemen. So yesterday, all right, so now off of dessert, back to math. So yesterday we talked about functions, and what was the definition of a function? And for each input, there's exactly one output, which is true for this too. This is a piecewise function. One input, one output, which means, should we get two answers? No, we shouldn't. Okay, it is a function. So if I'm looking at f of 1, what's it telling me to do? Input 1. Okay, where are we going to input 1? The top one, because 1 is greater than 0 is a true statement. And so we're going to plug that into the top one. 4, plug in a 1 minus 3 gives me 1. Good. So f of 1 equals 1. F of 0, what is that telling me to do? Input 0, and it goes into the top one again, because 0 is greater than or equal to 0 is a true statement. So we use the top one. So 4 times 0 minus 3 is negative 3. Great. And the last one, input negative 2. Where? The bottom one, because negative 2 is less than 0 is a true statement. So we plug it into the bottom equation, 2 times negative 2 plus 5. You guys are so quick. Thank you. Just wait till I test you on this and I give you two answers as one of the choices.
Well, there's two.
Just go test it.
3 of them you give us.
All right. Very good. Any questions on this one?
No.
What is what?
You know what she was trying to
That's it. Yeah. Evaluate the function. Plug it in, get an answer.
Just one letter, and then we're all like,
Example 2.
I think it's
I would start seeing that pattern, and she should make one of them a different letter so that she knows who gives her. I'm careful.
Example 2. Determine the domain and range of the given function.
This is gonna be a short day.
Determine the domain and range. So for some of these, domain, a lot of times we can solve for and do algebraically. So I'm going to show you how to do the algebra for part A here because you'll have to do it in for later on problems. But it's always a good idea to graph these as well. So on B, we're just going to do it graphically. Right now, you don't know how to find the range algebraically. We'll talk about that later. So we have, for range, we have to go to the graph. Okay? All right, so we're going to do, first, we're going to look at these graphically. And so I need you to take out your calculators. And these are functions. When in doubt, graph it out. Please plug in the square root of 2x plus 6. If you have the Casio, make sure you put parentheses. Radical 2x.
All right, I got.
Whoops. So f of x is the same as y. All right. So do y'all have it in there?
Yeah.
Yeah, you got to input it in your Casio. You got parentheses around your 2x plus 6.
So you put 0 in there?
What?
Watch it.
Oh, no, yeah, just leave it blank. Yeah. Yep. Go ahead and hit graph it. Draw it. Okay. I lovingly call this the square root swoop function. Square root swoop. You see the swoop?
Yes.
Okay.
It's like a
So all square root functions, all functions that have a square root have the same shape. All right, they're all this sort of swoop. I call it the square root swoop. And so when we look at this function, and again, rule of thumb, if you're using your calculator, you're going to make a little sketch. Where is this point of intersection here? What does it look like? -3. That's a very good guess. Can you double check that?
Yeah.
Yeah, okay, so it looks something like that. There we go. There's a great little sketch. So you can use trace and type in -3 and just see that it is at -3, 0. Always labeling ordered pairs whenever you have a graph, okay? All right, so if we want to find the domain of this function, we simply ask the question, how far left and right does the graph go? Looking at the x-axis, because domain refers to the x value. So look at that x-axis. How far to the left does it go? -3. We always go to start with the left because littler things have to go on the left. Order matters in math. And then how far to the right does it go? Yeah, infinity. It goes forever to infinity. Why do I use a bracket at -3?
Because it stops at
Because it stops there. I mean, exactly.
It includes -3. It's an actual point, -3, 0. It is actually there. Okay, good. Now, when we're talking about range, we ask ourselves how low and how high does the graph go, referring to the y-axis. So we look at the y-axis and we ask ourselves, what's the lowest y value?
0.
0. Right here, we have the ordered pair, -3, 0, and that's the y value, 0. So that's our lowest y value. And how high does it go? Infinity. Yeah, because this is going to the right a lot, but it is still growing up. Eventually, it'd get to infinity if we could wait long enough. I certainly can't wait long enough. So our lowest value is 0, and it goes all the way to positive infinity.
Which means the x value would be like a billion.
Right. If we could compound infinity, it sure would.
What is
All right,
for your range? Are you saying low as in
low to high, yes.
we can I just put R and D? Or
Yeah, so I'm always going to abbreviate domain with a capital D and range with a capital R. Yeah.
I didn't know if we had
Yeah. No. All right. So I do want to show you how to solve any even root always has a domain restriction, okay? And that restriction comes because can I take a square root of every number I could think of? Like even like negative 25? What is that? Oh, but that's imagine. No, plus or minus.
No, -1. Or 1.
Fine, and the
I don't
answer is no.
Okay, so this is imaginary, right? I can't really see that. Is that right? Okay, so when we're talking domain, this is what we can actually see. And so because anytime we have an even root, we can get imaginary answers, and we don't want to include any of those. So what we say is whenever we have a square root function, it must always be greater than or equal to 0. Why? We can't have a negative in there. If I were to try, I could square both sides to get rid of the radical. Well, so this is again saying the same thing. The inside must be greater than or equal to 0. We don't want it to be negative, okay? And then we can solve that. So we have 2x is greater than -6. Divide by 2, and we see x must be greater than -3, which is the same thing, okay? So this is the algebra for finding the domain, okay? And then so anytime you see a square root function, you can always, an even root function rather, you can always solve for the domain, telling it must be greater than or equal to 0. All right, this is an absolute value function. So I'm going to show you again. Does anyone know what the shape of an absolute value function looks like? No, it's not a squiggle. All right.
Is there a part where it doesn't?
Nope.
I did not pay attention.
Yes, you're going to graph this.
Man.
Okay, so how do you find, I need to delete this. Okay, absolute value, listen up. If you're a TI, absolute value is under the math menu. So right now you're in y equals. You've cleared your function. You're going to go to math.
Oh, we did see this one.
And arrow over to num and ABS. You're in y equals. You're going to go to the math menu. Math.
It's right under.
Arrow over to num and ABS is your choice you want to choose. All right. And we're going to type in x minus 3. And then on the outside, we're going to say -4. And you can graph that. For my Casio amigos, you're also in the y equals menu. And you're going to hit exit. No, you're going to option. You're going to hit option. And then you also have a number menu in UM. So you're going to hit num, and there ABS is absolute value. So I'll come over and look. So we have x minus 3 and then -4. Okay, go ahead and graph those, ladies and gentlemen, and look at the domain and guess the domain and range.
No, I'm on it.
Okay.
Does this ever get zero?
No.
Okay. Just want to make sure. I didn't think it did.
All right.
I am doing
So, whoa, that's a very different graph. What the hell did I do?
We put minus one.
Oh, I put -1. Well, that's not right at all. Okay. Good. All right. So, there we go. So, looking at that function, if you were to graph it, what do you think that like lowest point there is? Negative. Well, what's the ordered pair? Like so. Yeah, 3, -4. Hey, look at that. You see those numbers in the function, right? Wow. Oh my God. It's amazing. Math. What? All right. So again, you can plug in using trace and see that this point is 3, -4. Absolute value functions always look like the letter V. It's an absolute value V. Okay?
Absolute value.
Yeah, that's how that works. What shape are square root functions? Square root. Swoop. Absolute value V. All right. So when we're talking about domain, we want to know how far left and how far right does the graph go? How far to the left does it go? Negative infinity. And how far to the right does it go? Positive infinity. It goes on forever in both directions, left and right. What's the range? How low does it go? -4 to infinity. What should I use at -4? A bracket. Very good. Range is how low does it go and how high does it go on the y-axis. So the lowest y value is right here at -4. And it goes up forever. Okay?
Yes.
You got that? Jacob, did your question?
We need to have a calculator for this homework.
Yes.
What happens if we don't have a graph?
You're going to look on your phone or at on your computer. You're going to go to desmos.com whenever you need to use a graphing calculator on your homework. Okay? What?
For S, do you start at the bottom or the top? Okay. Because the last one looked like the
You have a question?
Yeah.
Yeah? What's the question?
So for like the domain for B,
Uh-huh.
why is it negative? So then should it be just 3?
Wait, why is the domain?
Why is the domain that?
So we look at the x-axis. This arrow means what?
Infinity.
It goes up, but it's also moving to the left as well, right? So I'm gonna like right now my x value maybe is like -10, but in a little while it goes further up. Maybe it's like -100, and then it'd be like +100 for the y. It doesn't keep going. Yeah. So what is the farthest left x value? -infinity. Okay, because it's moving out forever. Does that make sense? Yeah.
So the left is always
Little. Yes. Yes.
No. Brackets.
Yes.
Yes.
Zoom 6. Zoom standard.
What? I can't hear you.
On what? 49? What about 49? I'm not. Are you doing the homework? Don't ask me questions on the homework when I'm not done with notes. Okay. Example 3. This is the last step here, which we've been taking way too long chatting. Okay. These are determine the domain of the function. Express domain using inequality notation and interval notation. Oh, I kind of like that. Okay. So there are 2 things right now that you have to look out for when you're finding domain. And these are the 2 things. Denominators Denominators cause restrictions in domain and also even roots. And so these are the two examples of things that we have to figure out the domain for. So this is a rational fractional function, and the denominator always gives us domain problems. Because if the denominator is 0, we would be dividing by 0, which is undefined. When the 0 is under, it's undefined. Okay, so we've got a crazy function here. I'm going to see, can I factor this? Can I double bubble that?
Sure.
What times what is 2x squared?
2x.
2x times x is 2x squared. And then what times what is positive 1? Positive 1 and positive 1. How do you know if you did it right? Check the rainbow. All right. 2x plus 1x gives us that 3x. So I know I did it correctly. Okay. All right. So because we have this denominator, denominators are not allowed to equal 0. Which means we're going to go ahead and figure out what those are. So we're going to set each bubble and say, hey, you're not allowed to be 0. And hey, you're not allowed to be 0. Neither of you can be 0, which means x cannot be what?
-1
And -1.
Good. All right. So x cannot be -1/2, and x cannot be -1. These are the restrictions for the domain. And in fact, this happens to be inequality notation. I think your book says all real numbers except x equals -1/2 and x equals -1. This is fine.
Oh, we're doing
The what? These are the two things we have to look out right now that are going to cause domain issues. Right? When you see those things, you're going to get problems with domain. Usually, domain is negative infinity to positive infinity, just like your absolute value graph. It goes forever to the left and forever to the right. So whenever you come across denominators with x's in them, or even roots, there's always going to be a shrunken domain.
Is that the answer?
That is the inequality notation. Everything but those two numbers. Yes, exactly right. It could be a cube root or a fifth root. Those actually work just fine all the time. Okay, so this is inequality notation, but I want to show you the interval notation as well, and I'm going to do it graphically. I have -1 is an open circle. I'm not allowed to be -1. And -1/2 is an open circle. But as Noelle said, everything else works. Everything to the left works. Everything in between works. And everything to the right works as well. So if we want to find the interval notation answer, then I need my intervals. You'll notice there are 2 excluded values. How many intervals does that create? 3 intervals. So -∞ to -1.
We have to do this for a whole.
I don't know. And then
I'm not going to do that.
-1 to -1/2.
This graphic.
And
I know.
-1/2 to infinity. So
Use brackets.
can you use brackets?
No, it's right.
Right. So we're not allowed to equal -1.
For the homework, you know, interval notation says
I want you to follow the directions. I don't know what the directions say.
determine the domain of the function.
Oh.
So
I
just
think-
put interval.
I think your book uses this.
That would make
In
that
pre-cal, we use this. So I'm showing you both. Okay. All right.
Running out of time.
Now, yeah, I'm going to run out of time, so we're going to do one more.